The way that these older systems tended to work was that you had a centralized repository, so this was like your gospel, this is where your source code worked, and people would extract a single file, make a modification. There was called a checkout, so you check out a file, you modify it, and then you check it back in again. One of the biggest drawbacks of this method is that if I check out a file to make a modification, you, for example, could then check out that file until others have done mine, and it caused lots of problems because it wasn't distributed in nature. It related to people being able to use files at the same time. And as software got more complex, you would often have larger teams working on it. And so it was actually a roadblock rather than being an actual enhancement to version control. What happened back in about 2005, a guy called Linus Torvald, who some of you may know has been, I guess, the granddaddy of Linux, the creator of Linux, they were using a different system. And the problem they had was that the system they were using, which was a distributed version control system, they had lost the license, the freedom to use it, so they wanted to create something new. And so with a blank slate, they created Git. And so Git was firstly created for Linux itself, for the kernel level development of Linux. And it was in 2005, and it's gained popularity very quickly. The reason, well, the primary reason is the distributed version control system. So what that means is that each developer who's running off a repository, a Git repository, has their own copy of that Git repository, so that they're keeping essentially their own version control of Git. And each person, we could all be working on one master repository of Git, and each have our own clone of that repository. We go on a happy merry way doing our own thing, and then push all our changes back into that one centralized repository as we wish through what's called a merge. Now the advantage of this is none of us is held up by that old check-in, check-out process. So if I was working on something and someone else wanted to work on the same file, there's no problem there. We can both do so. If we create conflicts in what we do, we can we go through a conflict resolution, which is going through line by line, but that doesn't actually happen that often in a practical sense. It creates a separation of entities, so this is again alluding to the fact that I can go off and do my own thing and you can do your own thing, and each person can work in their own little contained environment where they're not affecting anybody else. Another of the side issues which it allows is also security and backups, and this is a byproduct of it. It's not actually the intention of Git in any way, shape and form, but for example, my company, we use our live website, so when we produce a website using Joomla or any other platform, it's always done using Git. And when we have that site on a live server, it's actually running off a cloned copy of the repository, so it's actually got its own copy of Git running on the server. Something that we'll see shortly is that it keeps changes. Now, one of the advantages of this is that, for example, say that site gets hacked through whatever means, and the hacker, as is common, may insert malicious code into existing code. So one of the most common hacks, if a hacker gets access to your site, be it Joomla or any other site, they will insert sometimes, it'll be encoded base 64, encoding and things like that, to embed into a normal file. So it could be, historically, used to be a configuration file or your index file, they may embed some code in there. And the advantage is, if that site's running on Git, we can immediately see through the version control that there's been a change to that file. And I'll demonstrate that a little bit later. But what it means is we can actually see, if the site has actually been hacked, we can see exactly what's happened to the line, to the actual. Okay, so I kind of jumped this, but so it came from a lead originally within the Linux community, built by Linus Torvalds and others in April 2005. As we stand as of today, it has about a 33% adoption within developers. That's Git within software engineers in general. So it's very popular. Others that you may hear of nowadays, and another quite popular one was actually one called Mercurial. Mercurial actually came from the exact same need as Git. So when they created Git, another guy went off it for the same purpose of helping out Linux and created Mercurial, and actually are very, very, very similar. And if you came, I actually started on Mercurial rather than Git because coming from an SVN background, the idea of Mercurial was that he made it very similar to SVN, so it was a natural progression. But the world chose Git, and so eventually I sort of jumped over Git as well. Okay, version control systems have their own little language, but it's a fairly common language, and there's a whole heap of terms, and these are basically commands that you'll use within the version control system, and they're common These ones are Git specific, but some of the terminology is common to others, such as Macquarie and so forth. So when we talk about a clone, which these are terms we'll be using a little bit later, so when we talk about a clone, we're talking about the actual cloning of a repository. So if you imagine I have a repository sitting in Bitbucket, for example, on GitHub, most people go to GitHub, that's where Joomla sits. I can clone that repository, so I literally get a copy of everything that's sitting in that Git repository, and I get my own copy on my own computer. And I can then go and do my own thing with that. I can change the code, I can fork it, I can do whatever I want to do. Then there's the terminology of a commit. So if I change a file and do nothing, then in terms of Git, nothing happens. But if I change a file and then I commit that file in Git, and we'll see this in action shortly, that means I have basically logged that change within the Git system. So Git is now aware of the change to that file, and it is now a part of the history of that file. So if I look back in that file's history through all the changes, I will see that entry. But that only happens once I've committed the file. One of the biggest sort of things that a lot of new people or new users of Git will do is they'll make changes and they'll forget to commit them. Until they're committed, they're not part of the Git system. Once they're committed, if I then deleted the file, I can go back to it because it's a part of that Git history. If you haven't committed it and you delete the file, it's gone. And you only do that once. I did it once on a very major project where I had an entire folder with a couple of dozen files, which has been best part of a week's work. It was for a big company at West Farmers, so a company that everyone knows here. They were expecting results, and the day before I was due to show them, I was meant to show them on the Monday, and on the Friday I deleted the folder by accident because I hadn't committed it. I just lost a week's work. You only do that once. Never make that mistake again. Needless to say, I spent that weekend redoing a week's worth of work. A push. So if I've done a commit, a push is the act of actually pushing that commit to a centralized repository. So generally, whilst you can run Git completely on your own laptop or on your own desktop, you'll have a centralized repository, and that could be somewhere like Bitbucket or GitHub, where you could run your own, your company may have their own, and that's the act of actually pushing all your changes, your committed changes, back up there, and you can do them in batches. So you may do a dozen commits, and at the end of the day, do one push back to the centralized repository. A pull. A pull is when we grab the data that's come from a repository. So if we're in a shared environment, so soon the guys are going to be looking at maybe redoing the Joomla.org website, and there may be a repository for that. So Tim may be working on that, doing some work on it. Here in Sydney, here there might be, and I might be over in Perth, where I live, and I'll be able to get their changes, and if I need to make a change, I'll be able to do it and change it, and they'll be able to grab my changes. So it creates this synergy between developers who are literally all over the place. And that's why it works for Joomla, for example. Back a long time ago, Joomla was an SDN. And the problem in those days was we had a distributed development group, and in fact in Mambo as well. But if I checked out a file to work on it, no one else could do it. Anything with it. Everyone was like 13 times waiting for Shayne to put that file back. Okay, branch. Branching is something which we'll show you as well. Branching is, within your Git repository, it's making an exact copy of a certain point in time of the Git repository, and then you can work on that branch, and you can make changes without affecting the main code repository. When I show you this in practice, it'll become more clear. Lastly, there are a lot of more, but the last one which we'll touch on is tagging. And tags is really just like a bookmark. So if you imagine you've got three different versions of some software, and you'll see this if you go to GitHub and look at Joomla, you'll see tags. And the tags are where they do a release generally. So they'll go, at this point we release 3.3 or 3.3.3, whatever, and that becomes a tag. It's not commit as such, it's more like a bookmark to a certain point in time of the history of that. And you can, at a click of a button, go back to any tag in history. So if I wanted to see what Joomla looks like on 3.0.0, I could go back to that tag, and now I'll be running that. So it's a very easy way of just creating logical steps. You can actually go to any point in time, any commit you want, but tagging just allows you to sort of identify major milestones within your development process. And I'd stress at this point, it's not just something you use for software development. So website development, where you're site building, can utilize all these things as well. We use them on a daily basis, both on our software development side and also on our website development side. So I'll be demonstrating that shortly. There's lots of different ways you can use Git, and over the last, since 2005, there's been schools of thought about how you could actually utilize this tool, because the tool is just a tool. It's a toolbox, so like you have a toolbox, how you use those tools will determine a different outcome. Centralized is where you have a central repository. It could be in GitHub, it could be on a company server, and everyone is basically running off one stream of development, and they're kind of doing their own thing and committing back. It's actually harks back to the old SVN and CVS days, but it's not one which I recommend. It is still used, but it's a good starting point if you're just on your own playing with Git, just do that. A features model means that you have your centralized stream of development, and each time you want to do a feature enhancement, you create a copy or a clone or branch in this case. You do your feature enhancement. Once you're happy with that, you merge that back into your central stream of development. That one works quite good. It's good if you're on your own or a very small group. Git flow is probably the most common within an internal development team. So if you're in a company and you've got a bunch of internal developers, Git flow is a really nice one, which I will be going into a bit shortly. And then last, you've got simple forks. Forks is actually what you see happening within Joomla. So if you go to Joomla repository in GitHub, you'll see that on the top right-hand side you'll see forks. And it's an interesting term. When Git first came out, the term fork was a bit of a dirty word because that was in 2005. And what else happened in 2005? We forked Mambo, and I was part of the team that did that. And we were at loggerheads to say that Joomla was not a fork of Mambo, that was the continued development of Mambo under a different name. So forking within the open source community back in 2005 was very much a dirty word. And when Git turned up and one of its primary sort of control mechanisms was forking, it was a bit of a what's up with this? But in actual fact, as you'll see, if you look in Joomla, it's a fork. And what happens each time someone forks, they're actually cloning it. So within GitHub, they're getting their own copy of the Joomla repository. They can then go and make changes and do lots of cool stuff and do what they want to do. And again, they're in their own little container. They're not affecting anyone else. They can do what they like. They could be a team. So I have a fork which my company has, and we could play with things within there as a company. And if we ever wanted to, we could do the next step, which is we do what's called a pull request. Pull, you might remember, was sending data back to a centralized repository. Now, when it's your own repository, you just you push things back. In a pull request, you can say to Joomla.org, I've done some changes on my copy of Git, and I'm inviting you essentially to pull those changes back into Joomla. So you'll see, for example, bug fixes and things like that. If someone has fixed it in their own fork of Joomla, they can send a pull request back to the main Joomla repository saying, I fixed this issue, here's my change. It's essentially an invite, in layman's terms, an invite to pull that change back into Joomla's central repository. And you'll see that that does happen, both at a core development level and also in bug fixes and stuff like that. Okay, yeah. This doesn't show up overly well, but this is Git flow. So this is one of the development models that I was talking about. Now, if we have a look here, this is what we call our master branch, this line here. Now, what the master branch is, that is your production site. So in a website context, that is your absolute working live site. What's sitting on your server, that's what everyone sees when they go to your server. So that's your Bible site. The other one of immediate importance is this stream here, the development. So the development branch, you might call it a staging branch or a development branch or various things like that. Now what that is that's your centralized developer model. And a lot of companies or organizations will run a separate development copy of the site. So if it's a Joomla site, you have your live site internally or maybe externally, but under a protected URL or something like that. You may have another copy of the site running, but it's running off the development branch. So there are your two main branches. Then there's two scenarios where things may happen. Where are we? Hot fixes. If something breaks, it's an emergency fix, something that needs to happen yesterday. It's a security release, for example. they will be done by branching. I mentioned branching before. So taking a copy of your master, you apply your hotfix and make sure it works. You're in your own little container, so you're not actually affecting the large site. You're doing this probably locally on your own laptop or desktop. You make the change, you confirm that it works, and then once you confirm it, you merge it into the master branch and you bring it back to life, and then update your live website. At the same time, you send your change through to development, so your development branch is also up to date with the hotfix. So your developers who are working on that branch, they will grab a copy of that and they'll get that change. So you have, with one change, being able to push it back to there, to live, back into development, and your developers will have grabbed that change if you have multiple developers. So that's a hotfix. Most websites evolve over time, so you'll be doing things that are actually adding an extension, for example, or modifying things, changes to the template. You may create extensions yourselves, you may hack Joomla itself, you may have to do that. All those kinds of things you do in a feature branch. And a feature branch, so as you see in here, we just have basically some bits and pieces. Now, for those of you, one of the really cool things about Git, anyone who was in SVN days, SVN used to put hidden SVN files everywhere. Every single folder had SVN files in it. You can see those because they were hidden, but they were there. And it meant that the idea of running a live site off it, you had all these hidden SVN files everywhere, which was not really good practice. It was pretty shabby. If we have a look in here, you'll notice in there, so this is through terminal. I'm looking at that same folder that we were just looking at. And you'll see forget the .git store, that's just a Mac thing, but that .git is a folder. The entire Git repository and its history will sit in that folder. It's not distributed through the entire file base. Likewise, you'll notice if you go back here, now that's looking at this folder here. So we're looking in this folder here, which isn't the public folder. So this is actually sitting below public. It's not going to be a part of your public-facing HTTP site, as opposed to SVN, for example, which has stuff strewn all over the place. So it actually makes it quite useful, it works nicely with websites because you can keep stuff that you don't want public out of the public view. And then with the appropriate server setup for security reasons, it means that it's all going to be nice. This isn't something you would typically do on, say, a shared hosting environment. You might have access to it. So what I did just earlier was we've got that site sitting there. Now, if I go to my personal preference, which is source stream. So what I've got here is that same folder, and this is the Git representation using a Git bind. So I created a Git repository and I put I put everything in there. You'll see that here it says I've got 5,267 changes. So all we'll do now is this is a very quick way of just adding them. So I'm adding all those files, so now what it's saying is it's taking all those files and making them part of my Git history. You mentioned, I said we commit it, so now we'll commit it, and we put a message, so here we just put. I'm not going to push the changes because we're on a network, but if I commit that, they're now part of my Git history. Now, here's the thing, if I go into that file base, okay, so this is that same folder structure that we were just looking at. Okay, so we might just go to the index file. Okay, so I've made a very simple change there to that file. Okay, we come back here. You'll notice that it's got one there. It's noticed that someone made a change to that file. And you'll notice over here, she tells us what that change was. Now, if that was a legit change, I could then commit that change. Normally, in these notes, you would actually put something meaningful to development. What it is that you've actually done, so that appears in your stream and allows developers to see what you're doing at the time. And I can commit that. So that's now a part of that Git history. So if we go back to it, we look at our master branch now. These are two versions. So there's the initial one that I committed, and then there's the next one. You'll see here it shows me what changed. Now, over time, you'll see that this actually can be quite beneficial because you can see where every single change happened within the history. the site. So next we have branching. So that's our master. Now typically, and I mentioned that a lot of, you'll notice here Git flow. So Git flow is actually inbuilt into source tree. So I can click on here, I can modify this, but basically it sets up my basic source flow structure. So I'm going to have a master branch and a development branch, like you saw in that graphic earlier on. And it's also going to indicate how I'm actually going to prefix any feature release or hotfix branches that I might use down the track. So this is, you don't have to use it this way. This is just a very, very vanilla way of using Git flow. But for beginners, it's a really good way just to get. So you see now that I have a development branch and I have a master branch, you notice it flipped to the development, because you shouldn't really be developing in your master branch. You should be doing it in your development branch or whatever you choose to call it. So the next thing I might do, you'll notice that I'm in the development branch. So if I go back to code here and we get rid of that change, okay, you'll notice that that change took place. So I'm going to commit that, let's go. And we'll commit that change now. You'll notice we've got two branches now. We've got the development branch, which we now know doesn't have my change in there. If I was to flick over to the master branch now, what do you think we're going to see? It's still there. And the reason it's still there is because we made that change in the development branch. We haven't modified the master branch yet. And this is where your branching model comes into play, because you have different branches that have different code bases essentially. When you're ready, I can then go merge development to master. Now what that's going to do is take the changes that I've done in my development branch and merge them into the master branch. So now if we flip back to development, now if we go to master, and we have a look at the code, it's gone now. We're in the master branch, and we no longer have that because it's merged that removable of the code from development. It's now getting merged into master. That in a nutshell is how it works. It gets way more complex over time, and as you get more proficient at it, you can do some really, really cool stuff. But at its nuts and bolts level, that's what it's all about. And you'll see that if we go to the history now, you can see the changes that have taken place through the different branches we can swap through. I could then go to the master and say this was ready for release. I can go create a tag. And we could just crack that to us. Sorry, okay, so now you'll notice it's not actually made a change to the history there. All we've done is created a tag, which, as I mentioned, is a bookmark really of a certain point in time. So as we went down in development and made further changes, I could, at any one point in time, I could just go back to that tag and go back to how things were there. Any questions at this point? Cool. Like I said, it was brief and focused.
One question, does that work with GitHub as well, source tree?
Yeah. It integrates with it actually. It'll actually query account into the source tree and it'll recognise where you get it accounts.
Oh, okay, cool.
It'll see your repositories.
Do you think there'd be an advantage in this if we're a smaller company owning a couple of us, and we use staging sites at the moment, and we take advantage of SiteGround staging sites now as well, which make things simpler. Would it be worthwhile putting those sort of sites into GitHub? Because really we're just duplicating what we're doing anyway.
At the end of the day, use what works for you.
Yeah.
I
mean, as a programmer, and some of the stuff I do low level, this is obviously great.
You could do it for the stuff before it gets to that. So
yeah.
It depends on your own work methodology as to whether it would fit or not.
Yeah, I just think we'd be duplicating by GitHub.
Quite possibly. I must admit, I'm not familiar with what the SiteGround do, and it could be that it actually it could actually be Git or something.
Yeah, well, all we're doing is creating a copy, exactly that. And
so I'm not familiar with it, but if that was the case, it may not be necessary. So yeah.
Just wanted to ask with Gitflow, because when as I've set it up in that before, it's generally been, how we've done it is generally just been from feature branching and stuff. And so with the Gitflow and how that kind of set up your developing that and set up, it just kind of seemed to automatically set up that connection between the two. Is that an additional feature for Git, or is it built within Git, like from a command line if I was setting up on the
It's
server?
actually not doing anything outside of Git, it's just using Git to create that.
So what is Git flow? Because sorry, I just haven't heard of that
Git
before.
flow
It's
is,
hooks.
yeah.
There's a hooks folder that they
Yeah.
write in C, and they write
Yeah.
code to do a lot of those things for you.
It's really, Git flow itself is, if you look at the feature set of Git, you said, how am I going to use that? And then you documented a method of using it. That's all it is. It's a documented method of using the existing Git.
Yeah.
The thing is that it got quite, when it first came out, it got a bit of traction.
Right.
And I fell in love with it. I was working on a big European-based project, and I was one of the small group of us in this part of the world, and it was useful for us. There's a lot, and people like Source Tree actually integrated it into the system as you start to just.
Yeah,
So that's a very vanilla version of it, but it's one that's good for a starting point.
It's worth reading that blog post too. If you go to Gitflow, the guy who wrote the original blog post about it, it's only about 500 words. It's really, really good though. It's really nice system.
Definitely. I've got the link actually. Anything else?